Agradecemos a los integrantes del panel por su participación, a la ingeniero Karen Barraza, al doctor Cecilio López, al maestro Felipe de Jesús Sandoval y al doctor Manuel Certuche. Soy la doctora Mariela Alfaro, líder de la Unidad de Investigación de Procesos de Manufactura para Materiales Avanzados en la Ciudad de México, del Institute of Advanced Materials for Sustainable Manufacturing, la cual está diseñada para desarrollar investigación enfocada a empresas que conforman el sector industrial de la manufactura, en específico aquellas relacionadas con procesos de fabricación que operan en ambientes inciertos, las cuales enfrentan grandes retos derivados del cambio climático. Para ello, esta unidad plantea el desarrollar tecnologías que estudien las necesidades de la industria en cualquier etapa de procesos de manufactura, generando modelos de transferencia y asimilación tecnológica que permitan a la organización adaptar la tecnología a sus procesos. Esto busca lograr la optimización de recursos y la mejora de calidad con una visión interdisciplinaria, que involucra capacidades intelectuales y tecnológicas de un equipo con bases en ingeniería industrial, bioprocesos, nanociencias, instrumentación, control automático y ciencia de datos. Con esta investigación esperamos tener un impacto en reducción de CO2, reducción de consumo de agua y optimización de la producción. Esto, aunado a la colaboración con las demás unidades del instituto, nos permitirá brindar soluciones de manufactura sostenible. La conferencia a continuación se titula Future Technologies for Advanced Materials and Manufacturing, a cargo de la MBA SWRI Rogers, Manager Manufacturing and Robotics Technologies Department del Southwest Research Institute. Sara.
Thank you, Dr. Alfaro. Thank you all for having me today. Hello, buenas tardes. I am going to start off with some numbers. So, 154, that is the number of cumulative years of Tec de Monterrey and Southwest Research Institute's existence. And Tec de Monterrey, was founded in 1943. Southwest Research was 1947. Just a few years later, in 1951, our two institutions began working together. Some of those first projects were the disposal of steel mill waste and the process of improvement for glass, rubber, and insulating material. And that was the beginning of the Institute of Industrial Research. A not so great number is, in the last year, there were about 500,000 reported accidents in Mexico at work. So the future of manufacturing should help avoid some of those things. Let's talk about some more fun numbers. There are 44 robots for every 10,000 employees here in Mexico. But that doesn't really compare to Singapore, that has 918 per 10,000 employees. It's a little bit far reach. They are skyrocketed higher than any other country out there as far as the industrialization with automated systems. So let's bring it down to the 10th most robot-dense population, and that is in Belgium. They have 214 industrial robots for every 10,000 employees. If you haven't figured it out yet, I'm going to be talking about robots. A fun number is 52. That's the number of Cocomelon songs my son made me listen to while I was working on this slide alone. Yeah. So I'm hoping everyone here already knows about Tec de Monterrey, because you're all here and you found it. That's cool. But I'm going to talk to you about Southwest Research Institute for just a moment. Our mission is to advance science and applied technology to benefit government, industry, and humanity. We're an independent nonprofit. That's apparently a little confusing here, but that means that we don't have grants, we don't have foundations. We have customers who value our work and continue to return to us and bring new customers to us to work, again, on that applied research and development. One of the things that makes us relatively unique, but it sounds like Tec de Monterrey is also in this sort of capacity is that we have a wide array of scientists and engineers specializing in all sorts of different skills and knowledge areas. So if I'm working on a robotics project, but I need to know something about hypersonics, we have that. If I'm working on a robotics project and I need to know something about hydrogen energy, we have that. So we're able to work together and develop things that are much greater than we would be able to do if we were working alone. What I'm going to talk about today. Not everybody here has the same background as each other, so we'll start out with some definitions to level set. And then I'm going to talk about why robotics really is part of the future of sustainable manufacturing. I'm also going to talk about remanufacturing, and I will finish up talking about some other simple robots based on the definition I'm about to present. So, IEEE defines a robot as an autonomous machine capable of sensing its environment, carrying out computations to make decisions, and performing actions in the real world. Since I'm going to be talking about that for the next 25 minutes, let's break that down segment by segment. So an autonomous machine is a machine that does not require human intervention for every step along the way. So it might require a button push at the beginning or a confirmation that what it's about to do is appropriate, but a human is not involved in every aspect of what it's about to do. Capable of sensing its environment. So that can be as simple as receiving an electrical signal to begin working, or it could be receiving a signal from a safety sensor that it should stop working to not hurt people. Make decisions, performing actions in the real world. So lots of people talk about simulations. A robot that's in a simulation, by this definition that we're using today, is not a robot. A simulation that is performing simulated welding is not actually doing anything. It's just changing ones and zeros. I'm talking about robots that actually have an effect on things in the real world. So a sensor for this conversation is anything that allows a robot to understand its environment or information about itself. So this includes cameras, accelerometers, strain gauges, infrared sensors. Any of those things count as sensors. Digital twin. This phrase has a lot of different definitions all over the place. For the sake of today, we're going to say that it is a digital representation of an object that's real in the world. And finally, remanufacturing. It's not just reconditioning, it's not just recycling, it's restoring a part to like new or even sometimes better than new quality. So let's start with a very simple example of how robots help with sustainability. In the normal paradigm, let's take sand casting. A part is cast in sand. It's roughly accurate to the dimensions that it was planned to be. And the sand casting process does not allow for precision measurements. So certain holes and other manufacturing processes require a human to then do additional post-processing once the part has cooled and hardened. Humans make mistakes, so there's inspection. And when there's inspection, sometimes the parts fail and either have to be scrapped or they have to have rework. And that takes, if it's rework, it takes more money, more energy, more time, and then you get a finished product. So if you take that same example and you substitute in a robot, it's able to do what that human was doing in this example, grinding or boring a hole, and it will do the exact same thing every single time. So if the manufacturing process ahead of the robot does not change, then what the robot will do to that part will not change either. And you will get the same part. You should probably still inspect, because that's always a good practice, but that part should pass every time. I recently found a case study that talked about an engine manufacturer, and they substituted a robot in their cylinder head processing, and they were able to reduce their defect rate by 50% by using a robot instead of a human. That increased their productivity by 25%. That saves energy, that saves time, that saves money, that creates a more sustainable manufacturing site. Less energy. Robots consume, in general, less energy than a human performing the same process, both because the robot is going to be able to do it more accurately each time, but also robots don't need some of the creature comforts that we as humans need to work in high precision environments. For example, it's about 70 degrees in here, Fahrenheit, and we would be absolutely losing focus if it was the same temperature as outside. Robots, in general, aren't going to care as long as their process is optimized to handle what environment they're working within. It doesn't matter. They facilitate things like a lights out factory. Now, that doesn't mean that the entire factory has no lights on, but the areas that are predominantly held by robots are going to not need all of the HVAC, the lighting, all of those other things that a human does. Robots also don't drive to work. I don't know if you knew that, but so that also allows factories to be further out, allowing you to have a beautiful city like you have here in Monterey. And so it allows those facilities to be further out. Robots also don't have bias. I was recently shared by a manufacturer of drills that their inspection process for their drills was by a human listening to the transmission sound. They have batches of about 200 drills at a time. The down-end process had a problem, and the whole batch was basically bad. But the human inspector listened to the first drill, rejected it, listened to the second drill, rejected it. But by about halfway through his shift, he started passing these drills that should never have made it into packaging. And so the drills went out, were sold, and there were warranty claims. A robot is incapable of second-guessing itself. It can throw up a flag if it's programmed to and say, hey, this is outside of the normal numbers, but it can't start changing the way that it was programmed. Robots increase throughput. They don't get sick. They don't go to lunch. They don't go to the restroom. They don't go on vacation. They don't quit and then need retraining when somebody else replaces them. All of these things decrease productivity. They decrease the quality. And so the throughput will increase. You probably have heard of collaborative robots. Collaborative robots are force and speed limited. So they're meant to be around people. They're inherently safe until they're put into a system that is not safe. Like if you put a knife in a collaborative robot's hand, it's not safe anymore. But they work much slower than typical industrial robots. But even so, they work tirelessly. They'll work round the clock. So think about the jobs that people leave in manufacturing. They are typically jobs that are dull, dirty, and dangerous. If somebody is doing a tedious job, they stop paying attention and they start making mistakes. And mistakes are when safety issues happen. Somebody can cut a finger off in a manufacturing process, or worse, hurt themselves to the point that they're no longer with us. Robots, when implemented correctly, can significantly improve safety. And of course, all of these things combine together to the bottom line that industry wants, which is saving money. So here's a video of a robot working with an advanced material. So in this robot, we have two collaborative robots. Again, I mentioned that they're force and speed limited. And because of their force limitation, they are able to also sense how much force they're exerting on a thing. So one of the robots is holding a ply of pre-preg composite, and the other is using a paddle to do the layup of that composite to a mold. This is possible. In the past, even today, the majority of carbon fiber layup is done by humans. Those humans tend to have significant quantities of repetitive stress injuries, which is not a good thing, because then that highly trained, highly skilled employee can't do their job anymore. And we need to not have that be what happens. We also have the ability for robots to help with additive manufacturing. Typically, additive manufacturing is a 2- or 3-dimensional robot. It's on a gantry, and it can go up and down. But then post-processing of additive parts can also be done with robots. There's also a new field that's emerging called metamorphic manufacturing. That's a robot doing blacksmith operations. This is not a new technology, but again, it's a very dangerous, very hard, very high turnover technology that we want to help enable people to not have to do so they can do other jobs. So far, I've been talking about robots that are programmed to do one specific thing repetitively, over and over again. Now I'm going to talk about some of the ways that we can create smarter, more intelligent, more adaptive robots. My team has developed what we like to call Scan and Plan, and it is a fusion of robots with sensor technology to increase the intelligence of those robotic solutions. And it is the foundation for production deployment for high-mix and low-volume applications, where previously it would have been infeasible to put a robot into that sort of facility. These robots are able to see what they're working on. So when you include things like artificial intelligence or machine learning, they're able to have enough understanding to know when to stop processing a part. So previously, if a carbon fiber part was needing to have paint removed from it, a human would have to do that sanding, because the human would have to say, I've sanded enough, I'm going to be done. But now a robot can say, I've sanded enough, I'm going to be done, because I'm starting to see that carbon fiber peeking through. So here's an example of a Scan and Plan application. This is a robot that is going to autonomously paint an airplane wing. So it starts out with a LiDAR-based scan. LiDAR is a laser detecting robot. And from that, it creates a point cloud. The point cloud is used to detect collisions so that the robot can go in and do a higher detailed scan with a 2D camera. We want to get close to the surface, but we don't want to hit the surface with the 2D camera, because then we'd be out of 2D camera. So the 2D camera information is fed into the system, and it creates a mesh. A mesh is basically a solid model of the surface of that part. And then it starts beginning to plan the process by finding the normal points to the surface and then creating paths between all of those different points. And then using open source software like MoveIt or TrageOpt, it's able to figure out how the robot is going to move through each of those points. Then it paints an airplane wing all by itself, never having seen an airplane wing ever before in the existence of this robot. This is extensible to more than just painting. It's extensible to grinding, cold spray, welding, and many other processes. The neat thing is this saved 30% of the time of a professional finisher. So somebody who paints wings every single day took 30% more time than the robot did. And the robot was able to achieve a much more consistent thickness of the paint across the whole surface. All right, the next topic is digital twin. And so that last video, I showed you how a mesh could be recorded to provide a digital, and it could be recorded to provide a digital history of that part. You could record information such as the processes done to it. You could record any inspection history. You could record repair history. And this is not useful for all parts out there, but it is useful for serialized and important parts. So in the near future, we can use those records to inform companies when preventative maintenance should be taken. Earlier I said that robots don't get sick and don't take vacation, but sometimes they do need maintenance. And maintaining a robot or any other system, like an aircraft engine, is much better to do before something breaks. Breaking things can be catastrophic. So further down the line, we can use digital twin information to inform on other parts that have failed, so that when a part goes through an inspection and that inspection is compared to a part that failed and its inspection history, a company can better understand when that part should be removed from service permanently or when it should be fully repaired instead of let to go back in. So I just talked about a part that maybe you take out of work and you don't use anymore. So what do you do with that part? In the past, it went into a landfill. And that's kind of a waste, and that's not part of sustainability, which is why we're here today, right? So remanufacturing is a big part of that. Remanufacturing is what can be done when a part can no longer be used in service in the state that it's currently at. It's the industrial process to restore a product to new or like new condition. So let's talk about some of the benefits of remanufacturing. Material conservation. You don't have to get that material out of the earth again. So if you have a steel part, you still have a steel part, and you don't have to go get more steel and harvest it. You also don't have to do the majority of the processing that is very high energy to do things like melting the part or melting the metal to do things like sand casting. Those processes are very high energy. Energy consumption reduction. You also already have a part that's what we call a core, which is essentially the same geometry as the finished part that you want, that just needs some sort of work that's done to it. Waste reduction. I think that's obvious. Sorry, clicked the wrong button. Go back. Thank you. Waste reduction. There are less things going into the landfill. We're able to better use the materials that we have that we've already manufactured and that are still good and viable. Cost reduction. All of those other things, again, take money. We don't want to remelt the material. We don't want to remanufacture the core. Or manufacture the core again. We want to take the part and just remanufacture it, make some slight changes, and make it better. Job creation. 450,000 people today are employed in jobs where remanufacturing is a part of their job description. It creates jobs. It doesn't get rid of jobs. This is probably my favorite robot ever. It supports a remanufacturing application. It supports sustainability. It supports all of our goals with advanced technologies, advanced manufacturing. Roughly every 5 years or so, airplanes need to have all of their paint stripped. They need to go through an inspection to make sure that there aren't any significant cracks on the skin of the airplane that would cause catastrophic damage. Airplanes falling out of the sky, kind of a bad thing. Today, airplanes are stripped by one of 3 methods, or a combination of those. Chemical stripping. Chemicals create some toxic residue, toxic wastes. Sanding creates sanding pads that are now waste. Or grit blast creates waste of the grit blast media that is used to remove the paint from the airplane. All 3 of these are not so great. Boeing says that it takes about a week, a little bit more than, to remove paint from an airplane the normal way. What we've developed is a carbon dioxide-based laser stripping robot. It has a vacuum that sucks up the paint that's being ablated, removed from the airplane, and the only waste is that paint that's being taken off. So there's no more additional consumables. This takes 3 to 4 days. Carbon dioxide lasers do take a lot of energy compared to somebody grit blasting, but you're able to do the whole plane in 3 to 4 days. So all in all, it is a savings on energy, which is more sustainable. So far, all of these robots have been really big industrial applications that support manufacturing. Now I'm just going to talk about some very, very small robots, again, based on that definition that we explored about a half an hour ago. And these robots can be used to support sustainable manufacturing too. These are sensors with switches in them that can be used to control the environment. They can be used to control electrical usage. They can be used to control water leaking when it's not expected to. All of these are wasteful. All of these reduce sustainability. All of these increase our carbon footprint. So even something as simple as an occupancy sensor for a room can turn off the lights after everybody's left. That little extra percentage of energy usage that's avoided by the sensor turning off the lights helps. Now, I hope that you all agree that robots are a technology for today and the future for sustainable manufacturing. Let's go back to some numbers. Next year, Tec de Monterrey and Southwest Research will have 156 cumulative years that our institutions will have been in existence together, and we'll have 72 years of collaboration. Now, these next numbers are a challenge to you to the folks in manufacturing, to government, to students. Let's find a way to be safer. Let's find a way to decrease the number of work-related injuries each year in Mexico. Let's also do that by increasing the number of industrial robots here in Mexico. Now, you might not know it, but employees tend to stay interested and involved in their job when there's robots and automation involved. And in fact, 86% of employees are not considering leaving a job when they're working with a robot or automation. Even if their job is robot tender, they're more excited about that than metal grinder. So, the future of manufacturing involves automation and robots. They need to be carefully implemented to be safe. They need to have people, employees, students trained to use, to develop, and to create these solutions for our future. I welcome any questions that you have.
Muchas gracias, Sara, por tu presentación. Tenemos unos minutos para responder un par de preguntas al público presente. Si tienen alguna pregunta, por favor, levanten la mano. Y de igual forma, vamos a tener algunas preguntas por streaming. ¿Podrían pasar el micrófono atrás, por favor?
Thank you for the presentation. You know, from the engineering point of view, the advantages of using robots are very clear. But always, especially with collaborative robots, there is an underlying discussion about the ethical issues, you know, especially thinking about replacing humans in factories and so on, so on. What is your opinion about that, especially after your experience working with these solutions?
Sorry. Ethical factors of bringing robots into jobs that humans are doing? Mm-hmm. Okay. I think it's very ethical. There are jobs that humans are better at than robots, and humans should be doing those jobs. I think it's especially ethical when you see some of the tragic accidents that happen in machine floors, where people lose their lives and lose their limbs, where fathers and mothers don't come back to their children, or they come back as less of a whole person because they don't have their arms or legs or hands anymore. I personally cannot imagine going back home to my son and not being able to hug him anymore. I think that robots don't take jobs away from people. I think they give people a new opportunity to raise themselves up to do something more. Robots don't program themselves. People need to program them. And there are very accessible ways of programming them that don't take a master's degree or a PhD in robotics or software engineering or systems engineering or any of those skill sets. There are accessible ways for people to kind of point and drag and cause a robot to do something very useful. There's still a lot of jobs out there, and robots tend to fill a need where those people keep leaving the jobs. And if they keep leaving the jobs, there's got to be a reason why. They're not happy. They don't feel that they're paid enough for the job that they're doing. They're scared of losing their hands or arms or anything like that. So I think that it's unethical to not look for opportunities to get people out of dangerous situations.
Okay,
Thank you.
Tenemos una pregunta más por streaming. What do you think will be the greatest benefit of robotics in manufacturing?
I think robots can help expedite some of these new technologies to market. Like Dr. Bolovic was talking about earlier, there's that 10, 20, 30-year wait for some of these new technologies to get to market. And with robot technology, with the way that we can program robots to do more adaptive and more interesting things, I believe that robots will help get these new things to market sooner. I can imagine some of the technologies that my team has worked on that would facilitate some of those non-stick coatings that he was talking about. And I'm anxious to collaborate with him later. So, yeah.
Okay. ¿Tenemos alguna otra pregunta por parte del público? Ahí tenemos una.
Thank you, Sarah, for your presentation. It was really nurturing for me and this kind of knowledge. I was wondering, maybe this question is more around the policies of automation or automatization, but how can we ensure that people that are being replaced by robots, in maybe more on the side of legislative policies, in terms of the ethical movements that a company is going to do. For example, you mentioned people moving to the cycle of material conservation and energy consumption reduction, the 5-step cycle. How do you think this will take place in a more judicial system?
I would love to see more programs that help employees who had traditionally been doing the same jobs as the robots are able to take over, have some sort of retraining, either to work with the robots and support them and support those processes that they're creating and that they're going through, or for something else. I mean, there's products coming out of there, so there's supply chain issues. There's people ordering those parts, so there's order fulfillment activities. There's customer service demands. All of these things require people to help support. And I know that there are institutions within at least the United States that help bring some of this retraining to people. I'm not aware of if those initiatives exist here, but I believe that those sorts of things where employees are able to learn a new skill that isn't a readily replaceable skill, are definitely things that government and the companies that are installing robots should be taking part in.
Thank you.
Thank you.
Okay.
Hello. First of all, good afternoon, and thank you for coming, Sarah. And my question is, what do you think about the Industry 5.0 term? Have you heard of it? And do you think it's a new industrial revolution with all the elements it's adding to the form we work?
So for those of you who are not familiar with Industry 5.0, Industry 5.0, Industry 4.0 is bringing all of these intelligent systems together to work and create more than a sum of their parts. Industry 5.0 is bringing humans back into that integration and having humans working within those smart systems to make it even better than those systems alone can be. Are you guys able to pull up a video that's hidden in the very next slide? Because if you could do that, I actually have an answer that I just wasn't building into the whole conversation. We've done work in human-robot collaboration. There are activities that humans are definitely far superior at, especially dexterous sorts of actions, and even with semantic segmentation in artificial intelligence and machine learning, the ability to recognize all of the facets of a part or finished product is definitely reduced. And so we've done some work with human-robot collaboration. We have a group that has developed a technology that can see a human and figure out their skeleton within a system of cameras. And so it can detect a human. And one of my roboticist team members decided, hey, what if we took that, which is used for things like sports enhancements and helping prevent injuries for military applications. What if we took that and we downsampled? We don't need all of the fingers and toes, but we have just kind of the broad parts of a human, and let a robot see when a human enters its work cell. So I guess they can't pull up. Did they? No. Yeah, it's hidden because, yeah, I didn't know. Yeah. But we have a robot that is able to see a human entering its cell. And so let's say that the robot is programmed to just do a simple pick and place sort of activity, just grab and move. And a human enters it. The robot will be able to find the human and go around it by replanning its trajectory. It would also, thank you, stop if it can't figure out how to get around it. So the robot is supposed to be going right through where my colleague Ben is, but instead it goes around him. You can see the exoskeleton, or the skeleton that it has kind of created, and that's how it's detecting it. So yes, definitely think that humans have a place with robots. It needs to be done very safely. Right now we're doing it with collaborative robots because the collaborative robot is force and speed limited. But the goal is someday in the future that even an industrial robot maybe doesn't need to live in a cage or behind a light shield. And that's definitely a future that has significant opportunities for increased productivity. Thank you.
Ok, tenemos una pregunta por streaming. How much time, money does it take to train employees to learn to operate robots?
Well, it depends on what kind of robot we're looking at. For a very simple, repeatable process, there are people who can be trained to do that in weeks. My employees create very advanced applications for robotics. They all have 4-year degrees that support that. And it takes them a half a year to a year of on-the-job training to be really, really good at it. So there's a huge array. Thank you.
Thank you. ¿Una pregunta más? Okay. One last question. Could they be used to automatize the maintenance on buildings?
I'm sorry, what?
Could they be used to automatize the maintenance on buildings?
Oh, yes. Robots can definitely be used to automate the maintenance of buildings. So there's a robot that a startup in Austin, it's a city near San Antonio where I live. There's a startup in Austin that has a robot going around disinfecting rooms at hospitals. There are window cleaning robots. There are robots that can go and do a thermal IR view and look for cracks or places where energy is leaking in and out. So there's definitely more applications that can be created. Your imagination is the limit of finding those applications.
I am so curious about the role of robots in the metaverse. In the metaverse, in the virtual reality, because you show a lot of examples, physical robots, but in terms of virtual robots, what is the main role of those robots?
The role of the robots in the metaverse?
Yeah, in the metaverse. Because companies are moving over there.
So again, by kind of the definition that we used at the beginning, the metaverse is not a physical thing, and so they're not really doing anything in there. However, there are augmented reality and virtual reality applications that robots can be used in, especially long-distance inspection. So perhaps a part needs to be inspected and the inspector doesn't have enough knowledge to decide that the part has definitely failed, and so they need somebody who has even more experience. And a long-distance inspector from another facility could use their AR headset and look at all of the different parts of the part and zoom in and even perform like a CMM sort of inspection through augmented or virtual reality.
One more question.
So how do you, but do you see that as a good training for people so we can really do better our work of programming or enhancing the robotics and the human labor? Using this type of new technologies, you know.
Do I see evolution of the way that we're training?
Yes.
That's a great question. I got to get here yesterday. I arrived later than I wanted to, but early enough to come see Dr. Munoz and his students and some of the, here at Tech, and some of the work that they're doing. And they're solving real-world problems. They have a submarine that is able to go through the water, detect an obstacle course, and go through those obstacles. So there's search and rescue operations with drones that use the same sort of technology that they're developing. There's the ability for a boat to automatically correct its trajectory based on the way that the water is moving. And do path planning through a bunch of obstacles. And that path planning isn't very different than a robotic arm doing path planning through a cluttered area, or avoiding a human, as in that last video that's still playing. So I'm impressed and hopeful that this newest generation of roboticists, of automation creators, of computer scientists, and all of the other terms that are being generated to support these new multidisciplinary skills that people are building. I'm very hopeful that this will continue advancing technology, advancing industrial use, and moving us forward to a future that's more sustainable and safer.
Okay.
Thank you.
So thank you very much.